morning, good evening, good afternoon, depending wherever you are viewing me on this channel. The channel is called Applied Science College, and I'm Chancellor. I'm introducing you now to our series of practicals, of titration practicals. Now we are going to do titration practical 5, back titration. You are provided with 1. Hydrochloric acid solution, B. Sodium carbonate solution, Q, containing 2.7 of sodium carbonate in 250 cubic centimeter solution, methyl orange indicator. You are required to determine the concentration of solution P in moles per liter. This is the procedure now. Using a 10 mils measuring cylinder, measure 10 cubic centimeters of solution P and transfer it into the clean 250 volumetric flask. Add about 200 cubic centimeters of distilled water and shake it. Add more distilled water to make up to 250 cubic centimeter solution. Shake the mixture and label it as solution R. Pipette 25 cubic centimeters of solution Q into a clean conical flask. Add 2 to 3 drops of methyl orange indicator and shake. Fill the burette with solution R. Titrate the solution Q with solution R from the burette. Fill the table below, this table. Now, we are required to calculate the average volume of solution R. First, before we do that, we will make assumptions of the results and then we tabulate it in this table here. First of all, we will be able to, we assume that the titration has been already carried out. And after we have already carried out, automatically we started the initial reading on 0.0. Maybe we, in the burette, we started the titration from 0.0. We fill it in the first column of the titration table. Then from there, we will titrate, and then let us now assume maybe the solution changed at 33.3. Now, we go to the second titration, because now we are consuming a lot of solution R in the burette. Now, we are supposed to refill the burette. Let us assume that now we refill the burette up to 10.2 mark. So we write here 10.2. Then we titrate, then we assume that the solution changed at 43.4. We come and tabulate our results here. Then we go to the third column. We assume now we fill the burette up to 5.4 mark. So the 5.4 becomes our initial burette reading. So we record it here at 5.4 like that. Then from there, we assume now we have titrated, then our solution maybe it changed at 8.9. We come and tabulate our results here. So after we have done that, we are supposed now to subtract the initial burette reading from the final. So after we have done our subtraction, it's going to give us that 3.3 here, and then here it's going to give us, if we do our subtraction properly, we are going to get that 3.2 here. That 3.2. Then finally here, if we do our calculations properly, it's going to give us that 3.1. So the volume of the acid used, the average volume of the solution R used, supposed to be R here, R used in cubic centimeter, we are going to add, we will say average volume of solution R is equals to this 33.3 plus 33.2 plus 33.1. So it's going to give us, we divide everything by 3. It's going to give us, if we do our calculations properly, it's going to give us 99.6. So we write here 99.6. divided by 3. We go back to our calculator. 99.3 divided by 6, giving us 16.5. So we write here 16 point. Let me see it properly. Okay, it's supposed to give us 30. It's supposed to give us. Let me repeat it again. 99.6 divided by 3. It is giving us 33.2. Supposed to be 33.2. So we write here 33.2 cubic centimeters as our average volume. Then we have been asked, question B, determine the number of moles of solution Q used. So in this case, we are going to write an equation so that we can be able to know what is supposed to be done. So we will come here and write, because it is between hydrochloric acid plus sodium carbonate. So it's going to give us sodium chloride plus sodium chloride plus carbon dioxide plus water like that. So these are liquid, this is gas, and this is an aqueous. This is aqueous. This is also an aqueous. So we are supposed to ask ourselves, within the reactant side and the product side, is our equation balanced? When we look in our equation, our equation is not balanced. So we are going to balance our equation. So how many hydrochloric acid do we have here? They are 1, and this side there are 2. So we write 2 here, so that we find out if the reactant side and the product side it has been balanced. So we find out, we try to go through the compounds that we are reacting. Sodium hydrochloric acid here, it has 2 hydrogens. On the product side, it also has 2 hydrogens. Chlorines are 2. So this side is supposed to be chlorine. This side are supposed to be 2. There are 2. On this side it's 1. So we are going to write here 2, so that we have 2 chlorines on this side and also on the other side. Sodium atoms here are 2, and also this side there are 2. So that our equation is balanced. Carbon, we have carbon this one side atom, this carbon atom on the other side. Oxygens. How many oxygens do we have on this side? 3 oxygens. On the other side, if we combine, there are 3 oxygens. So our equation is balanced. Now we have been asked, determine the number of moles of solution Q used. The number of moles. So our mole ratio here is going to be 2:1. So after we have written our mole ratio like that, we are supposed also to go to an Excel and ask how much volume has been used in both. So now here, hydrochloric acid, the average volume is what? 33.2. So we write here 33.2. And then this average volume, the volume that has been used here, it is 25 cubic centimeters. After you have done this, now you are supposed also to ask yourself, for us to get the number of moles of solution Q used, we must equate these equations. We must be able to equate the equations to this in this way. We must go to an extent of calculating the number of grams that were dissolved first. Because we have been told here 2.7 of sodium carbonate were dissolved in water. So here we must be able to calculate the number of grams that were dissolved, first of all, we need to equate we need to approach it this way. If 2.7 were dissolved, grams were dissolved in 250 cubic centimeters, what about in 1,000 cubic centimeters? So after we have done that, now we can be able, we cross multiply this, we get 2.7 times 1,000 cubic centimeters, then over 250. All this is the number of grams per liter. So if you do your mathematics properly, we are going to get 10.8. 2.7 times 1,000 divided by 250 is equals to 8.7. 10.8. 10.8 grams per liter. After you have done that, I'm just trying to economize some space here. 10.8 grams per liter. After you have done that, now you are supposed also to ask yourself this question. Molarity is equals to mass in grams per liter over RFM. R, sodium carbonate. Sodium carbonate, you take the R relative formula mass of sodium carbonate. Sodium in that compound, we have 2. So we are going to get 2 times 23. And then carbon is 12. 1 times 12. Then we also have oxygens. Oxygens are 3. So we are going to multiply it 3 times 3 times 16. So when you do your mathematics clearly, you get here 46, you get here 12, you get here 48, which will total to 106. If you do your mathematics clearly, you will get 106. So we substitute here so that we get the mass in grams per liter. We have been told it's 10.8. So we are going to substitute this to give you 10.8 divided by 106, which is going to give you, if you do your mathematics properly, you will get 0.1 molar. And remember, the equation, our question is asking to determine the number of moles of solution Q. So the number of moles of solution Q, we are going to ask ourselves, the number of moles is equals to molarity, the number of moles. Now, we are going to equate this. If 0.1 moles are in 1,000 cubic centimeters, what about, because we have been told to calculate the molarity of Q. And remember, R, we have been told to determine the number of moles of Q that were used. So, if that were used, so we equate here 0.1 moles in 1,000. What about for 25? 25 is the one that was used to pipette. So we equate it here 25 cubic centimeters. 25 cubic centimeters, we cross multiply. here, we get 0.1 0.1 moles times 25 over 1,000. That is 25 over 1,000 cubic centimeters. So if you do your mathematics clearly, you will find that the number of moles that were there, they are 0 point is equals to 0.0025 moles. I'm trying just to economize the space. Then question that is A, B. We have answered A, B. This is A, B. And then we are going to answer C, the number of moles of hydrochloric acid. The number of moles of hydrochloric acid. Then we have been asked to calculate the number of moles of hydrochloric acid. So the number of moles C determine the number of moles of HCl. Remember our HCl determine the number of moles of hydrochloric acid, solution Q. This is solution Q. So now, after we have been able to calculate the number of moles of this, because we have determined the number of moles of solution Q used. So we have answered A, B. Now we are answering C. Determine the number of moles of hydrochloric acid used. So this one is R. Solution R. Now we have answered Q. Now we are answering R used. So we are going just to write an equation because of the mole ratio here. The mole ratio. If the number of moles sodium carbonate and HCl, the mole ratio here is 2:1. 1:2. Let us now say like that, according to this arrangement. Now, the number of moles here, we have found they are what? This is now the sodium carbonate. Where is it? The number of moles of solution Q used. Solution Q used, it is what? Sodium carbonate. So, if sodium carbonate can be able to give us this, what about for this? So, they are going to be 0.0025 times 2 over 1, which is going to give us what? 0.0025 times 2, which is going to give us, if you do your mathematics very well, it's going to give us 0.005 moles. 0.005 moles. We have answered that. Then D. D, we have been told to calculate the number of moles of Q of R in 250. Calculate the number of moles. The number of moles number of moles in 250 cubic centimeters of the solution. So in this way, we are just going to write like this: 0.005 moles were in 33.2. Remember that 3.2 is here. That 3.2 is here, which is R. Remember, this is R. Then X moles were in 250. X moles were in 250. So we are going to cross multiply here. 0.005 moles times 250 divided by 33.2. So we go back to our calculator very fast, and then we do it like this: 0.005 times 250 divided by 33.2, which is going to give us, 0.0, which is equals to 0.037 moles. We have answered that. So, I'm just finishing. We have been asked to calculate the number of moles in 10 cubic centimeters originally in the hydrochloric acid in solution P. The number of moles determine, that is E, determine the number of moles in 10 cubic centimeters of HCl. 10 cubic centimeters original. The keyword is original. In original HCl. Solution P. Solution P. So in this one we are going to approach it this way. We are just going to write the number of moles in 250 solution is equals to, in 250 cubic centimeter solution is equals to the number of moles in 10 cubic centimeters of solution M. Is equals to the number of moles in 10 cubic centimeters of solution M. So now, because of the mole ratio, we have already calculated this. These are the number of moles that we are talking about. So we are just going to say, which is equivalent to 0.037 moles, because the number of moles are just the same. So now we are going to calculate the concentration of hydrochloric acid of solution B. The concentration, we have been told to calculate the concentration of HCl, solution P in moles per liter. In moles per liter. You will say that 0.0 is supposed to be 0.0, this one, 0.037 moles in 10 cubic centimeters. What about in 1,000? So we are going to cross multiply 0.037 moles times 1,000 over 10 cubic centimeters. All this is concentration. If you do your mathematics properly, you are going to get 0.037 times 1,000 divided by 10. You are going to get the concentration is 3.7 mole. For those few remarks, that one has marked the end of our class, our virtual class today. We shall be coming more with more series of the same practical. Please remember to subscribe. Please subscribe. Don't just view and leave it like that. Subscribe, like, and share. Because what I've discovered, most of you just listen to the class practical, but you don't subscribe. Please just subscribe, so that you can also give me some encouragement to continue bringing you more practicals. Otherwise, have a good day, a good evening, and a good afternoon, wherever you are on the globe. Thank you for listening to me, and meet you next time in the virtual practical class.